Dear students, welcome back. This is the 7th video lecture, and today our session will start with homework sums. I have given you in the first 6 lectures homework sums. So we will solve homework sums today. So this entire lecture is for solving the homework sums. Okay. Now the first sum that we are doing today is of practice set 1.1. First sum. Observe the first sum. What is the first sum? The question reads like this. I will not write the question, but it is saying base of a triangle is 9 and height is 5. So what we will write? Let the areas of two triangles be A1 and A2, comma, their base is B, B1 and B2, and their corresponding heights B and their corresponding heights B, H1 and H2 respectively. H1 and H2 respectively. Now you know what is the first property? The first property of that chapter we have studied. Therefore, that property is called as by the theorem, by the property of areas of two triangles. Areas of two triangles. Recall the property. A1 upon A2 is equal to B1 into H1 upon B2 into H2. Now we have to find the ratio of the areas, they have said, right? So A1 upon A2 we have to find. So we write A1 upon A2 as it is. We are given base 1 9 and height 5. So 9 multiplied by 5, and for the other triangle the base is 10 and height is 6. So B2 is 10 and H2 is 6. Now we have to simply cancel. 5 1s are 5, 5 2s are 10, 3 2s are 6, 3 3s are 9. Now we multiply the numbers in the numerator and the denominator, which is equal to 3 1s are 3 upon 4, 2 2s are 4. Therefore, the ratio of areas of the two triangles, that is A1 is to A2, is equal to 3 is to 4. This is our value. Check your answers, and when you get the answer, use this box to show that this is the answer of the question. Sum number 2, 3, 4 and 5 of practice set 1.1 we had already solved in the first lecture. Now the extra sums which I had given, I think so you will have the extra sums or you will have solved them. I am reading the first sum of the extra sum. The ratio of areas of two triangles with equal heights is 7:5. So this is the answer 1 of the practice set extra sums of practice set 1.1. Okay, let A1 and A2 be the areas of two triangles. Okay, and they have given that the ratio of areas of two triangles with equal heights is 7:5. Base of bigger triangle is 14 centimeter. So A1 and A2 be the areas of two triangles. They have equal heights, and their corresponding bases be B1 and B2 respectively. Now it is said that the triangles have equal heights, right? The triangles have equal height. Therefore, recall the property that we have studied. Therefore, A1 upon A2 is equal to B1 upon B2 when H1 is equal to H2. Now we are given the ratio of the areas. It is given to be equal to 7 upon 5. 7 is to 5. Now it is said that the base of the bigger triangle. Now which is the bigger triangle? A1 and A2 are the areas. 7 is to 5 is the ratio of their areas. So naturally A1 is a bigger triangle. So B1 is the base of the bigger triangle and B2 is the base of the smaller triangle. It is said that the base of the bigger triangle is 14 centimeter. So B1 is given to be equal to 14 centimeter. Find the corresponding base of the smaller triangle. So B2 we have to find. All these values are given. Therefore, on cross multiplying we get 7 multiplied by B2 is equal to 5 multiplied by 14. Therefore, B2 will be equal to 5 multiplied by 14 upon 7. 7 2s are 14. 5 2s are 10. Therefore, the base of smaller triangle will be 10 centimeter. That is the answer. Okay. Please students, while solving this homework sums, keep all the extra sums which I had given you in front of you. Otherwise you will not have the question and you will get confused. So keep all the sums in front of you. Now let's go for the second sum. So this is the second sum. We are given BC, but BC is sum of BD and DC. The reason for this is B dash D dash C. Therefore this is 9. 9 is equal to BD is 3 plus DC. So 9 minus 3 is equal to DC. Therefore DC is equal to 6 units. Now they have asked us three ratios. First ratio is area of triangle ABD to area of triangle ADC. Area of triangle. Now see, okay, since this ratio is asked to find, we have to find the ratio of area of triangle ABD to area of triangle ADC. But we have to see that this triangle, okay, actually there are three triangles that you see. All the three triangles have same height. Whether it is triangle ABD or triangle ADC or triangle ABC, all the three triangles have same height. So what we write? That triangle ABD and triangle ADC have same height from vertex A. Now when the triangles have same height, then area of triangle ABD upon area of triangle ADC is equal to, the triangles have same height, so the areas are proportional to corresponding bases. In triangle ABD the base is BD and in triangle ADC the base is DC. So it is BD upon DC, and you know how to write the reason. A1 upon A2 is equal to B1 upon B2 when H1 is equal to H2. Heights are equal. So now what is BD? BD is given to be equal to 3 and DC we found here, DC is 6. When you can cancel, you get 1 upon 2. Therefore what is the first answer? Area of triangle ABD upon area of triangle ADC is equal to 1 upon 2. This is your first answer. Understand? We can cut this 1s are and 2s are. So answer is 1 upon 2. This is our first one. Now similarly we can solve the solve the second and third steps of this sum. Okay, I am writing the second ratio. So this is the second step. Similarly, triangle ABD and triangle ABC. Now changed. Triangles are changed. Triangle ABD and other triangle is ABC. Small and the big triangle. So triangle ABD and triangle ABC have same height from vertex A. So area triangle ABD upon area triangle ABC is equal to BD upon BC, because the base of this triangle is BD and base of this triangle is BC. Reason same. A1 upon A2 is equal to B1 upon B2 and H1 is equal to H2. Now put the values. BD is 3 units and BC is entirely 9 units. So 3 by 9 when we cut we get 1 upon 3. So the ratio is 1:3. So second answer, area triangle ABD upon area triangle ABC is equal to 1/3. This is the second answer, answer number 2. Okay, and similarly we can find the ratio of area of triangle ADC upon area of triangle ABC. Okay, so similarly triangle ADC now triangle ADC and triangle ABC have same height from vertex A. So area triangle ADC upon area triangle ABC is equal to base is DC and here base is BC. For triangle ADC the base is DC and for triangle ABC the base is BC. So DC upon BC, same reason. Now DC is 6 we have found here and BC is 9. 6 by 9 is cancelled. 3 2s are 3 3s are 2 by 3. So ratio of area triangle ADC to area triangle ABC is 1/3. This is answer number 3. So in this sum, all the three triangles that you see, triangle ABD, triangle ADC and triangle ABC have same height from vertex H, and so we are using the property A1/A2 is equal to B1/B2 and H1 is equal to H2 to solve all the three sums in this question number 2. Now we shall move for the question number 3 of extra sum. So as you have the third sum in front of you, it says that the ratio of areas of two triangles is 3:4. That is, we have A1:A2 is equal to 3:4. It is also said that the base and height of smaller triangle are 10 cm and 5 cm. You can notice A1:A2 is 3:4. So A1 is a smaller triangle as the number 3 is smaller than 4 and A2 is a bigger triangle. So B1 and H1 are the base and height of smaller triangle which are 10 cm and 5 cm. They also said that the base of the bigger triangle is 12 cm and then they have asked us to find the corresponding height of the bigger triangle. So by the property of areas of two triangles we have A1/A2 is equal to B1 into H1 upon B2 into H2. We have to substitute all these values. This ratio is given 3:4 is equal to base and height of smaller triangle are 10 and 5. So 10 into 5, whereas base of the bigger triangle is 12 and corresponding height of the bigger triangle we have to find. Cross multiplying this, we get 3 into 12 into H2, 3 into 12 into H2 is equal to 4 into 10 into 5. So we find H2 how? By carrying the two numbers 3 and 12 on this side. So in the numerator we have 4 into 10 into 5 and in the denominator we have 3 into 12. So we can cancel. Which numbers are cancelled? Only these numbers will get cancelled. Okay, we can see that 2 5s are 10 and 2 6s are 12. Can we cut this? Yeah. 2 2s are 4, 2 3s are 6. So finally what is left? 5 5s are 25, 2s are 50 upon 15. 3 3s are 9. Sorry, 3 3s are 9. Now when we divide 50 by 9, what do we get? 9 5s are 45. Okay, 5 is the remainder. We take 0, extra 0. So in the quotient we put a decimal point. Again 9 5s are 45 and the division continues. Okay, we keep on getting the same recurring digit 555 like that. So and they have asked us to find answer correct up to 2 decimal places. So the third digit in this division will also be equal to 5. Okay, and so what we write? Therefore H2 is equal to 5.555. Okay, like that, and this is a recurring digit. Now how to round it off? Okay, we know the rule of rounding off. Cut the third digit. If it is equal to or greater than 5, then cut it and increase the previous digit by 1. So it is 5.56. Okay, centimeter. This is the corresponding height of the bigger triangle. So our answer is the corresponding height of bigger triangle is corresponding height of bigger triangle will be 5.56 centimeter. Understand? This is how we have to write. Put a box around it. This is our answer. Corresponding height of the bigger triangle is 5.56 centimeter. We have found answer correct up to 2 decimal places, that is 5, 6. Okay, because our division of 50 divided by 9 is 5.555 and it is not ending. Okay, this is how we can solve the third sum. Now we'll have to solve the fourth sum. In the fourth sum we have ratio of areas of two triangles is 6:7. So A1 is a smaller triangle, A2 is a bigger triangle. Height of the smaller triangle H1 is 12 centimeter. H1 is height of smaller triangle. Why? Because A1 is a smaller triangle. And corresponding height of the bigger triangle we have to find. H2 we have to find where the bases of the triangles are equal. So we know the property. What is the property? A1 upon A2 is equal to H1 upon H2 when bases are equal. So when B1 is equal to B2. Putting the values, 6 upon 7 is equal to 12 upon H2. Simple sum, cross multiplying, 6 into H2 is equal to 7 into 12. Carry 6 to that side, so H2 is equal to 7 multiplied by 12 divided by 6. 6 ones are 6 twos are 12. So we have 7 twos are 14, which is equal to 14 centimeter. Therefore, the corresponding height of bigger triangle is equal to 14 centimeter. This is our answer. So very simple sum, because the triangles have equal bases, the corresponding height we can find by this property. Okay, so these were the 4 extra sums which I had given for practice at 1.1. Now we shall solve the sums which I have given you homework for practice at 1.2. Okay, you should have the sums in front of you. Find out please which sums I have given you for the homework. So this was the first sum in the home assignment for practice at 1.2. Here we are given 2 figures, and in each figure we have to find value of x. We have to find value of x where line L is parallel to side PQ of the triangle. You can see that these marks are there, that shows that these lines are parallel to the given side of the triangle. So now what you would write? Now in triangle, how to start this? How to solve this? In triangle PQR, what we have? Line L is parallel to side PQ. Okay, we know that line L cuts side PR at point A and side QR at point B, but it is parallel to side PQ. This is given. So therefore, by basic proportionality theorem, what we can write? RA upon AP. RA upon AP. You can also start, the naming of the segment from PA upon AR. Okay, now I have started from RA upon AP is equal to RB upon BQ. Why? Because of the basic proportionality theorem. Recall the basic proportionality theorem. A line drawn parallel to one side of triangle intersecting the other 2 sides in distinct points divides the other sides in the equal ratio. So we are using the BPT exercise. Practice set 1.2 is entirely based on basic proportionality theorem. It's Converse and 2 more properties, which we had studied in the next lecture. The 2 more properties means the property of angle bisector of a triangle and the property of 3 parallel lines and their transversals. But because these sums are based on BPT, we will have to solve this way. Put the values now. RA is 4, AP is x. We have to find the value of x. RB is 5, BQ is 10. You know what to do. Cross multiplying. X multiplied by 5 is equal to 4 multiplied by 10. So what is the value of x? X is equal to 4 into 10 upon 5. 5 twos are 10 and 4 twos are 8. So what is the value of x? Therefore x is equal to 8 units. This is how we have to find the value of x. Same way we can solve the second sum. Tell me what to write. In triangle LMN, line L is parallel to side MN. This is given. This is given to us. Therefore, which ratios are equal? See, the points of intersection are not given. So I can directly write like this. Therefore x upon 2 is equal to 4.5 upon 3. Please be very careful. This by this is equal to this by this. X by 2 is equal to 4.5 by 3, and not x upon 2 is equal to 3 upon 4.5. That way you cannot do. So I have written in order. X upon 2 is equal to this. Now how to get x? 3 multiplied by x, yeah, the x multiplied by 3 is equal to 4.5 multiplied by 2. So what is the value of x? X is 4.5 into 2 upon 3. 3 ones are 3, 3 15s are 45, but this is 4.5, so this will be 1.5, not 15. Now 1.5 into 2, which is equal to 3. Therefore the value of x is equal to 3 units. This is how we can solve the second sum, first sum, two sums in the first by using the basic proportionality theorem. The next second sum I have given, which is also based on converse of basic proportionality theorem. So you should have the second sum also in front of you. So these are the two sums in question number 2. In each sum it is asked that is line L parallel to side QR of triangle PQR. This is line L, okay, triangle PQR. Line L intersects side PQ at A and PB at B, and the lengths of PA, AQ, PB, BR are given. How to find out whether line L is parallel to side QR or not? For this we use the converse of basic proportionality theorem. So how to do it? First we will find ratio PA to ratio PA to segment AQ, that is equal to 7.5 upon 3. That will give you 2.5 upon 1. 3 ones are 3, 25 are 75, but it is 7.5. So it is 2.5 is to 1, result number 1. Similarly, we will find the ratio PB to BR, that is equal to 10 upon 4. We can cut this, 2 2s are, 2 5s are. Again this 5 by 2 can be cancelled, that will be equal to 2.5, and this is equal to 2 1s are 2. So 2.5 upon 1. This is result number 2. Therefore in triangle PQR, what do we see? We see that ratio PA upon AQ is equal to ratio PB upon BR. This we get from 1 and 2. That means line L divides the two sides in the same ratio, and therefore what we can say, that line L is parallel to side QR. Reason, converse of basic proportionality theorem. This is how, so in the first figure we have line L parallel to side QR. Check out here in the second sum. Ratio PA to, it is PX. So ratio PX to XQ is equal to 4 upon 12, which is cancelled. 4 1s are 4, 4 3s are 12, so it is 1 upon 3, result number 1. Second one, PY, ratio PY to YR is equal to 3 upon 7, cannot be cancelled, both being prime number, result number 2. We see that the two ratios are not same. Therefore in triangle PQR, what do we see? That ratio PX upon XQ is not equal to ratio PY to YR. Why? This we get from 1 and 2. 1 and 2. That means these are not equal. That means we have to cancel this equal to sign. The two ratios are not equal from 1 and 2. That means that line L does not divide side PQ and side PR in the same ratio. Therefore line L is not parallel to side QR. What is the reason? Reason is same like this previous sum. The reason is converse of basic proportionality theorem. So when the line does not divide the two sides in the same ratio like this, these ratios are not equal, then that line cannot be parallel to the third side of the triangle. Reason would remain the same, converse of BPT in both the sum. These are the two sums which I had given you for the homework. Along with this, question number 2 and question number 4 of practice set 1.2, I had given you homework. So we will solve that. Before we solve sum number 2 and 4 of practice set 1.2, I will solve two sums, second and third of question number 1, because I had solved only one sum. Now they have asked us whether ray PM is bisector of angle RPQ in each triangle or not. So we will find out. You know, the converse of angle bisector property we have to use here. What is it? Let us find the ratio of the two parts in which the ray PM divides side RQ. The opposite side RQ is divided into two parts. So RM, ratio of RM to MQ. What is the ratio? That is 6 upon 8. What is the value? If you cancel it, 2 3s are, 2 4s are. So 3:4. This is result number 1. Similarly, find the ratio of RP to PQ. Okay, it is 7 upon 10. Now we cannot cancel this, so this ratio is 7:10. We see that these two ratios are not equal. Therefore, what we write? Therefore, in triangle PQR, ratio of RM to MQ is not equal to ratio of RP to PQ. Okay, have we taken in the proper manner RM to MQ equal to RP to PQ? Yes. First, remember in the angle bisector property, we have like seen that bisector of an angle divides the opposite side in the ratio of the remaining sides. Here it is not given that it is the bisector, but how to take the ratio of the parts, that I had told you in the last lecture. So here I have found the ratio RM is to MQ first, which is 3:4, and then I found the ratio RP is to PQ. Okay, because with RM the corresponding side of the triangle is RP, and with side MQ the corresponding side is PQ. So if you write PQ by RP and you get something here, it won't be both the ratios, even if they become equal, your answer will not be right. Why? Because you have not taken the proper ratio. This is the way we have to take the proper ratio. Now we see that these ratios are not equal. This we get from 1 and 2. And when these are not equal ratio, that means this ray does not divide the opposite side in the ratio of the remaining sides of the triangle. Therefore, what we can say? Therefore, we can say that ray PM is not the angle bisector of angle RPQ. This is how, and what is the reason for this? The reason is converse of angle bisector theorem and the converse of angle bisector property. So converse of angle bisector theorem. Here also we can check out, okay, solution. This is the solution. Similarly, here also I will write the solution. So check out first which ratio we have to find. Ratio QM to MR. Ratio QM to MR. That is equal to 3.6 upon 4. Now remove the decimal point. This will become 36. So I have to multiply the denominator by 10. It will be 40. Now use the table of 4. 4 9s are 36. 4 10s are 40. So the ratio is 9:10. Result number 1. Now as I have taken ratio QM to MR, now I will take the ratio QP to PR or RP. So ratio QP to RP is equal to 9 upon 10, which is written as 9:10. Result number 2. We are seeing that these ratios are equal. Therefore, we have to specify that in triangle PQR, the ratio QM to MR is equal to the ratio QP to RP. This we get from 1 and 2, and it means that this ray divides the opposite side QR in the ratio of the remaining sides. Therefore, ray PM is the bisector of angle QPR, and the reason is again converse of angle bisector theorem. Converse of angle bisector theorem. So this is how, please write the reason. Reason also carries a mark. This is how we can prove whether ray PM is bisector of the given angle or not by using the converse of angle bisector theorem. Okay, this is how we have solved the two sums of question number 1. Now we will solve second question of exercise 1.2. So this is the second question. We have PM 15, this segment PM is 15, PQ entire side PQ is 25, PR entire side PR is 20 and NR is 8. We have to find out whether NM is parallel to RQ or not. So naturally, whenever we have to prove that line NM is parallel to side RQ, we use converse of BPT. Right? For line NM to be parallel to side RQ, line NM should divide side PR and side PQ in the same ratio. That means ratio PN to NR should be equal to ratio PM to MQ. So let us find out. Now we are given side PQ entirely. So what we would write in the solution? In the solution we write PQ is equal to PM plus MQ because P dash M dash Q. Now PQ is 25, PM is 15, MQ we can get. How much is MQ? MQ is 25 minus 15, that is equal to 10. Similarly, for other side also we'll find side PR. Side PR is sum of two segments, PN and NR, because these points are collinear, P dash, N dash, R. Now side PR is given 20, PN we don't know, but NR is given 8. NR is given 8. So 20 minus 8 is 12. So PN is equal to 12. Now we will find out the ratio. Ratio PM to MQ or PN to NR. So let us find PN to NR first. Ratio PN to NR is equal to, what is PN? 12. So 12 upon NR is 8. 12 upon 8, both are divisible by 4. They come in the table of 4. 4 3s are, 4 2s are. So ratio 3 upon 2. Result number 1. Then we will find ratio PM to MQ. Similarly, we can find the ratio PM to MQ. That is equal to, PM is how much? PM is 15. And MQ we found 10. Both will come in the table of 5. 5 3s are 15. 5 2s are 10. The ratio 3 upon 2 we get, which is same as the previous ratio. Therefore, what we write next step? Therefore,